Hello, good afternoon. My name is Massimiliano Vasile, as you heard, and today I'm here to talk about Stardust. And Stardust, as you heard, is a Marie Curie network funded by the European Commission and is all about two problems that are currently open in space engineering: near-Earth objects and space debris. And in the next 18 minutes, I'll try to convince you that everything that you have seen so far that looked like science fiction is actually science and engineering, and that what you think is the future is actually now. So let's start from near-Earth objects. What are near-Earth objects? They are a mix of comets and mainly asteroids. So most of the asteroids are here in the asteroid belt between Mars and Jupiter, and some others are along the orbit of Jupiter. And because of the perturbations of the planets, like Jupiter itself, and other effects, like the sun, the light pressure, or even the fact that these asteroids are heated up by the sun and then re-emit photons, okay, the orbits change with time. And some of these orbits, instead of being here, then they change so much that they fall towards the sun and they tend to cross the orbit of the Earth. And therefore, they are called near-Earth objects. They get very close to the Earth, and sometimes they can impact the Earth. So why is that a problem? Well, you can imagine that having an impact with an asteroid is not something that you want to experience. And in fact, this is something that happens more often than you might think. This is something very recent. On the 15th of February of 2013, you probably all know that in Russia there was a 20-meter asteroid that entered the atmosphere and exploded in the air, causing quite some damage. Okay, 1,500 people required medical attention, mostly because they were at the window saying, "Oh, look, 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 look." And then the shock wave crushed the windows, the glasses, and they were injured because of that. But this is not the only event that we experience in this century. In fact, at the beginning of the 20th century, a much bigger asteroid hit Russia. It's called the Tunguska Event. It was about 4 or 5 times the size of the Chelyabinsk event, and the airburst at that time would have destroyed completely an area like London and surroundings. Okay? Luckily, it hit Siberia and there was nothing but trees. So this made the news, of course, and you could see this everywhere. It was filmed. And we know that there are asteroids coming in the coming years. And the interesting thing is that some of them can be very well predicted. And so we know that they are coming. But in the case of Chelyabinsk, no one knew that that asteroid was going to hit the Earth. Hello. So if you look at the probability of impacting the Earth, you might find something like this. This graph is telling you the probability of an impact in terms of how frequent an impact with an asteroid is, and the amount of energy that is released depending on the size. So if you have very small objects, you have things that happen every year. You have shooting stars, for example. Okay? But they do not release much energy. If you increase the size of these objects and you go to something like Chelyabinsk, so about 20 to 30 meters, then you have so much energy released that is 25 to 40 times the Hiroshima bomb. And if you go to Tunguska, then you have, as I said, something that can wipe out an entire region, and you go down to something that can extinguish the life on Earth. That is supposed to happen not that often. Now, something like Chelyabinsk or Tunguska is supposed to happen every century or every few decades. But the interesting thing is that in the case of Chelyabinsk, we had a double event. In fact, this is the orbit of Chelyabinsk, of the Chelyabinsk meteor, but at the same time, we were expecting an impact, or not an impact, a flyby of this other asteroid, a bit bigger than the one that hit Chelyabinsk. And we knew that this one was going to fly by the Earth, and the flyby was very, very close. It basically was so close that it was passing by the GPS constellation, almost. And we didn't see this other asteroid coming that entered the Earth at a speed of 15 kilometers per second. So just to give you an idea, this is the meteor that hit Chelyabinsk, and this is the one that hit Tunguska, compared to other objects that you can recognize on Earth. Now, these kind of impacts, as I said, are very, very frequent, more than you can imagine. In the last 10 years, the Earth was hit by 500 objects, actually 570 by now. And you do not really notice this because most of them explode in the atmosphere, they don't hit the ground. Okay? But Chelyabinsk was a kind of wake-up call. Now, asteroids and comets are not just a threat, they're also a very interesting opportunity because they can tell us something about the beginning of the solar system. And in fact, it is believed that even the ingredients of life were brought to the Earth by comets. Okay? And even some of the elements that we find in the outer crust of the Earth are not coming from the inner part of the Earth, but are actually due to impacts with asteroids and comets in the distant past. So one main interest we have is that asteroids are so different, and there are so many of them, and they have so many interesting things to tell us that we really want to explore them. There are many more, of course, than planets in the solar system. And of course, some people decided that it was also interesting to retrieve asteroids or to mine them. In fact, they are rich in high valuable minerals, they are rich in water, some of them, so they can work as a way station if you want to go somewhere else in the solar system. This is an example of the NASA retrieval mission that is aiming at bringing one of these asteroids to Earth. Now, the other problem is space debris. Okay, we saw asteroids. We understand the problem with asteroids and also the opportunity that asteroids can represent. So what about space debris? Well, you probably all saw Gravity, which in fact is just a movie about space debris. And you saw what could happen. Well, it's not really completely realistic what happened in Gravity, but the risk of what you see in Gravity is much higher than what you might think. And if asteroids are a problem for the Earth because they can cause damage to our planet, space debris are a big problem because they can destroy our space assets. So you can forget about the GPS, you can forget about telecommunication with satellites, you can forget about Earth observation and weather forecast. So this is an image of pretty much how many objects we have at the moment around the Earth. And they're actually increasing. And one thing that space debris have in common with asteroids, apart from the fact that, as you can see, this look a little bit like the asteroid belt, is that they are, or they can be, grouped in families. Because asteroids generate more asteroids. When two asteroids collide, they generate children. So in fact, we talk about families of asteroids, parent asteroids, and the result of a collision. And unfortunately, space debris are in the same situation. So if you have a collision, as it happened in 2009 with two satellites, then you generate more space debris. The other problem is that they fall. Exactly as asteroids, they can fall down from the sky and hit the ground. And this is not really a pleasant experience because, as you can see, what we put in space is rather large and often is designed to survive the re-entry. So they don't really burn in the atmosphere as you might have been told. They actually hit the ground, and we have to be sure that they do not cause serious damage. Of course, a lot of the area that it can hit is water, but it's not always the case. The other problem is that if you are in space, it's very difficult to shield against a piece of debris. In this case, this is an experiment in a lab. If we take a 1.2 centimeter object and you accelerate it to the velocity that a collision or two satellites colliding can experience, and you shoot to a wall this thick, this is what happens. It's like throwing a stone in water. Okay, you have a splash, and then you have kind of shock wave that is detaching the back part of the wall, but you cannot put an 18 centimeter shield in space. It's too big, too heavy, so we can't have this. And you can imagine that astronauts, when they have an extravehicular activity, they cannot go around with an armor like a knight in the Middle Age. And the other problem is that, as I said, space debris generate other space debris, and they can reach a density such that you have a chain reaction, exactly as you saw in gravity. This is normally called the Kessler Syndrome, and unfortunately, if we go on as we are doing now, the increase of the objects in the regions of space around the Earth is reaching a critical point. Here you have two situations that are quite recent: the collision of two satellites, Iridium and Cosmos, that increase steeply the number of pieces of debris in space. And this is another event in which a satellite exploded in space. So we are here at 2012, and look at the number of objects that we know that are present in space. Actually, what we know now is that there are even more, over 20,000 objects that we can track. Well, so what to do? What to do about that? Well, that is what Stardust is trying to do. So this is our website where you can see more about our activities. What we're trying to do is to find a way to solve the problem of space debris and asteroids. So in both cases, we need to observe the sky and understand where they are and where they're going to be. So we have to find a way to exactly find their position and velocity in the future, because we want to be able to predict an impact with our space assets or with the Earth. And then the completely open problem from an engineering point of view is, what do we do once we know where they are? We need to remove the debris, and we need to deflect the asteroid. And there, the problem is that we don't have a technology that's been tested in space that can provide a viable solution. There we have many ideas, and that's what Stardust is about, trying to find good ideas to solve this problem. After that, we can exploit, of course, the asteroids, or we can make of the space debris something else, like we can recycle space debris. So of course there are differences. We can't really explode asteroids, space debris. We can do it with asteroids. We cannot impact space debris because they generate more debris. We know more about space debris than we know about asteroids, so we can do much more to remove them. So these are some of the ideas that we are studying. We do have nuclear blast. So what you've seen in movies like Armageddon is actually science. We are studying how to use different versions of nuclear blast to nudge the asteroid away from the impact trajectory with the Earth. The easiest way is actually to take a spacecraft and impact directly, ram into the asteroid. And this is actually the object of a number of studies and missions that are currently planned by the European Space Agency and by NASA. More exotic solutions that are in fact very effective is to use gravity, the gravity that is attracting a spacecraft to the asteroid to pull the asteroid away. Okay, so if you use ion engines here to produce a thrust, the gravity between the two is used as a rope to tug basically the asteroid away. And another thing that we are studying here at Strathclyde is how to use a swarm of lasers to ablate the surface and produce a rocket, sort of rocket engine. Okay, so the gas that is ejected through the ablation is thrusting the asteroid away. Even more complicated is to try to get rid of space debris, because as I said, you cannot collide, you cannot explode a bomb there, and so you need other solutions. So one way is to blow ions against a satellite, and in this way you produce a thrust, or you can use the electrostatic force between a tugging spacecraft and the defunct satellite. Or you can use lasers again, so you can ablate basically the space debris and produce a thrust and remove it. Other solutions that we are studying use robotic arms or robotic devices that can grab the object, manipulate it, and then remove it from a threatening trajectory or an impact trajectory with another satellite. Now, for each one of these, of course, you need a lot of understanding of what you can actually do in space, and each one of these solutions has to be viable in the sense that you have to be able to test it, you have to be able to operate it in space, you have to be able to even have it as a commercial option for a private company. But on top of that, each one of these solutions has to be legally viable. Because if I try to remove the satellite of another country, that could be a legal problem. The same happens with asteroids, because if I try to deflect an asteroid that is, for example, predicted to collide Russia and I move it on the United States, or if the predicted impact is on London and I move it to Paris, then there is a legal issue there because I'm responsible for a misdeflection. You can go to our website and also tweet or follow our tweets.